Hello, everyone. Here we're just trying to make up some time for the winter storm that came through. So I am making these videos. It's not ideal. It's not exactly what I wanted to do, but it will have to suffice. So here we've got chain rule. We just learned power and quotient rule. Excuse me, power, product, and quotient rule. This with chain rule is sort of the last rule, if you would. That is like a hard and fast rule. You need to memorize this for, what am I trying to say? Yeah, for the course. Okay, it's imperative. So chain rule. First, we're going to talk about reviewing composition of functions and then apply the chain rule where appropriate. So composition of functions is from college algebra. Composition of functions, remember, it's when you have well, pretty much this right here. Let's see. F of g of x is equal to f composed of g of x. This on the right is the composition. This on the right is the, what's the word I'm looking for? Not foundation, functional version. Hello, functional. And then, of course, if you switch it, we've got g of f of x equaling g, or this is g composed of f of x, equaling g of f of x. Notice that here f and g are the same functions, like f could be, I don't know, 2x minus 1, and g of x could be x squared minus 4x plus 2. I don't know, doesn't matter. So then we have f composed of g of x, or fog, if you would, is f of g of x. Oh, also, side note, y'all know I am human. I do tend to make mistakes, just like anyone else. So I'm sorry if there is a mistake in the video. I will try to correct it if I notice it. So back to the example. So this is now f of g. So x squared minus 4x plus 2, which now means for f, wherever there was an x, we're now inputting this whole term. So we have 2 times x squared minus 4x plus 2 minus 1, which in turn, after distributing the 2, gives us 2x squared minus 8x plus 4 minus 1. And then we have 2x squared minus 8x plus 4 minus 1 would be plus 3. So that's it. That is f composed of g. But if you notice, if we do g composed of f of x, so this is g of f of x. So making a substitution for f of x, this is equal to g of 2x minus 1, which now for g, wherever there's an x, we now put in 2x minus 1. So this is 2x minus 1, quantity squared, minus 4 times 2x minus 1 plus 2. And then, of course, we would simplify down, blah, 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 and then that's what we would get. So they give us, even though we have the same two f and g function, they actually give us two different functions. This is just a refresher reminder of composition of functions. What this is about is that chain rule allows us to take the derivative of things much, much easier if we've got a function inside of a function. That's the main takeaway here. So for the first example, let f of x equals 7x plus 5 and g of x equal x squared minus 3. Again, if I want to find f of g of x, which is also f composed of g of x, this is the composition way to write it. Going off the function notation is easier, I think. We work left to right or inside out. This is f of x squared minus 3. Now, as mentioned, we're putting g into f wherever there's an x. So it's 7 times x squared minus 3 plus 5. Hopefully after practice with the difference quotient, this feels a little easy or like old hat. But in any case, here we just distribute the 7 and then combine like terms. 7x squared minus 21 plus 5 equals 7x squared minus what? 16. And that's it. That is f of g of x. Here, the main point is just recognizing functions inside functions. So when we're looking at them as far as derivatives, we'll see something just like what we have here. The 7 times x squared minus 3 plus 5. This is something more along the lines you're going to want to notice for a derivative. Notice for deriv. So now you're ready for the definition of chain rule. We've got, oops, my pencil just fell. Let me grab that. There we go, pen, excuse me. So if we have this composition of functions, the derivative is the derivative of the outside function times the derivative of the inside function. So you're only taking one derivative at a time. So let me read this to you in math terms. F of g of x, or the derivative of f of g of x, is equal to f prime g of x times g prime, or f prime of g of x times g prime. So when I have something like this, y equals 3x plus 5 to the 7th, here, if I want you to label or think, like what's your f, what's your g? In this case, your g is the quote inside function. Inside means it's literally inside of something 90% of the time. The other percent of the time, the other 10%, it might be, let's see, in the denominator, so 1 over something. You will also look at it if it's an exponent, if it's a log, but logs and exponents have their own derivative thing as well. But chain rule comes in handy over and over and over again. So here, the g of x, I want you to work the inside first. Notice the inside first, that's 3x plus 5. And then the outside would just be x to the 7th, right? Because suppose I cover my finger where g is, and now my finger is the x. So that's why it's x to the 7th. So when I'm taking the derivative, it is the derivative of the outside. So suppose I've got, just this. And then instead of, I've got, g of x to the 7th. So suppose we have this. I'm trying to find y prime. Well, the first thing says, well, actually, this is just y. To find y prime, if I'm looking at it like this is just power rule, right? Because you're only dealing with the outside stuff first. So that's 7 of g of x raised to the 6th. So that's this first part. Now times the derivative of g of x. So I've got y prime equals 7 of g of x raised to the 6th times the derivative of g, which is just 3. Now plugging everything back in, this is 7 times 3x plus 5, oops, that's a 6, raised to the 6 times 3. So you take the derivative of the outside first, then the derivative of the inside. So outside, inside. Only one derivative at a time. Trust me, when things get a little more complicated, you will feel the urge to keep taking derivatives all the way down. So all in all, we have 21 times 3x plus 5 to the 6th. And you've just done your first chain rule. Yay! So now we just have a lot of examples realistically, is all the rest of the notes. So find the derivative when y equals 9x squared plus 4x minus 2 to the 6th. So y prime, remember I like to cover my finger of the inside. Remember, you're only dealing with the outside thing first. So typically that's power rule. So that's 6 times, this just gets repeated. So 6 times 9x squared plus 4x minus 2, now all raised to the 5th, right? We only did power rule. Then times the derivative of the inside. So we now have 18x plus 4. And that's it. You can leave it like that. I don't mind. One other way that students like the F and G version, do you, is that if I want D box, and I think the box is what throws it off, is that here, if I've got F of box, okay, then it's F prime times box prime. Maybe I should put the prime there. But you're only taking the derivative of the outside first, repeating the inside, and then taking the derivative of the inside. So it's first step, deal with the outside, second step, deal with the inside. But the inside gets repeated because it is there. It didn't disappear into the cloud or anything. For y, for 4, again, I recommend that you would trade this this root to an exponential, like so. So read it that this is 8x minus 3 to the 1/2. So now when you take the derivative, remember you deal with the power first, repeat the inside. So that's the first step. Notice my inside did not change. The only thing that happened is I did power rule. The exponent drops and I went down by 1. And then I take the derivative of the inside, which is just 8. If you want to clean it up a little bit, you can notice that 1/2 times 8 is 4. So it's 4 times 8x minus 3 to the -1/2. If you want to be a super overachiever, this is 4 over the square root of 8x minus 3. So pause the video and I want you to try 5 and, well, just 5 on your own. Okay, so hopefully you've given it a whirl. So y prime, or actually, let's relook at this. Y, reevaluated or rewritten, is 1 minus x squared to the 1/2. Y prime, I like to cover when I'm learning, just cover up the inside. Now, okay, I recognize that I'm only dealing with power rule again. So it's x squared of some stuff to the 1x times some stuff over, or to the, I can't speak, to the -1/2, right? The power came down or reduced by 1. So now whatever my finger was covering up, I'm just going to rewrite. Now, kind of what I'm pointing at is now what I'm taking the derivative of. So this is just -2x. That's it. Again, if you want to keep going, you can see that, okay, 1/2 times -2, that's a -1. So it's a -1 times x in the numerator. Remember, the negative exponent means we slap it down in the denominator, which then in turn becomes just a more pretty -x over the square root of x squared. Okay, example 6. Here, this is a little more complicated because we have x times this composition, right? We've got something inside. So here, we're not only going to do chain rule, but we also have a power rule. So this is power rule with chain rule. So like I mentioned before, this is why it's so important, imperative that you know all the rules up to this point, because now they're going to commingle. Here we've got a power rule with the chain rule. We'll have quotient rule with the chain rule with power rule, chain rule with quotient rule. Oh, see, I've noticed my mistake. This is why I like live teaching. Not power, but product. y'all would have caught that much faster. Product rule with chain rule. Multiplication means product. So remember product rule? If y is equal to f of x times g of x, then y prime is equal to f prime g plus g prime f. So here, our f, so to speak, is equal to x. My g is then what we're going to have to take the chain rule of. Oops, that should be a squared. 3x squared plus 7 all to the fourth. Some people, and if you want to do this, go for it. For a product rule, they like to take the derivative of the thing so that they can just kind of plug it back into the product rules pattern. So here with G, we've got chain rules. Remember, we're just dealing with power rule first. The inside just gets repeated. So 4 came down, reduced by 3, and then for sake of room, sorry, pardon me, the derivative of the inside, which is just 3x. So now over here, if we just want to follow y prime, f prime, that's 1 times g, which is 3x squared plus 7 to the fourth. Now plus g prime. You can rewrite this, or you can say, okay, 4 times 6 is 24x times 3x squared plus 7 cubed, and then times f is x. So cleaning it up, oops, excuse me, and I forgot my prime. Cleaning it up just a bit, we've got 3x squared plus 7 raised to the fourth plus 24x squared. It's x squared because you've got an x here and an x at the end, times our 3x squared plus 7 all cubed. And then that's it. Yay! Hopefully that wasn't too shabby. Again, hopefully not too shabby. So pause the video. What I want you to do is try 7. It's very similar to 6. The only difference here is that you've got 2 product rules. I'll kind of help you out. Right, so this is product rule. Oops, I'll say PR for product rule. Remember, y prime is f prime g plus g prime f. So if you want to call your f the x plus 2 cubed, and your g is the 2x plus 1 raised to the fourth. Now when you take the derivative of f and g, they're both having the chain rule. So pause the video, give it a whirl. Okay, so you're back. If I keep going with the pattern of just finding f prime, g primes, and fitting it all in here, we see that f prime is in 3 times x plus 2 squared, and then technically times 1 because that's the derivative of the inside. And then g prime equals, remember we're just doing power rule first, so the 4 pops down, repeat the inside. Now the exponent drops by 1, and take the derivative of the inside, which is nice because my finger's kind of already pointed right there, which is just 2. So if you want to clean this up, this is just 3 times x plus 2 quantity squared, where for g prime we've got 8 times 2x plus 1 quantity cubed. Now we can go back and put all the pieces together and say y prime is using this pattern, right? Okay, f prime g. So we've got 3 times x plus 2 quantity squared times g, which is 2x plus 1 all to the fourth, plus g prime f, 8 times 2x plus 1 cubed. So that's g prime, and f is x plus 2 quantity cubed. And then I say leave it like that, right? Because after this, you'd have to distribute, and no thank you. Hopefully that's what you got as well. I'm, like I said, I'm bound to make mistakes. Let me know if you see one. Hopefully I catch them. But, I am human. Y'all have been to class before. You know how easily it is for me to change a positive to a negative and vice versa. Let me move this page. Okay, in here, we've got chain rule with a quotient rule inside. So chain with quotient inside. So without really giving you any direction, I want you to pause the video and see what you can do. I'm going to give you a few hints if you want the hints, and then after that, pause the video and come back. So a hint is, remember that the quotient rule says you have f prime g minus g prime f all over g squared. So doing the same thing we did for the product rule, establish your f, establish what g prime is, and then put all the pieces together. And then once you have your quotient rule established, it's much easier for the chain rule because all you're doing is moving the 5, taking one down. All right, pause the video, give it a whirl, press play when you're ready. All right, so hopefully you're ready. You tried, gave it a whirl. So here, f, if I'm just going to ignore the outside and I'm only going to look at the inside, just dealing with quotient rule first. I'm going to call f x plus 6. So f prime then is just 1. G is 3x minus 2. Oh, I also kind of mixed up my pattern for you. Sorry about that. So G prime is just 3. So now fitting this into my quotient rule, I've got 1 times 3x minus 2. And again, I'm just following the pattern. F prime G, F prime G minus G prime F all over G squared. Whoops, excuse me. 3x minus 2 quantity squared. So this is the quotient rule derivative. So if I clean it up a bit, we've just got 3x minus 2 minus, I'm going to distribute this 3 and the negative actually, minus 3x minus, what is that, 18 all over 3x minus 2 quantity squared. And then notice what happened. Oh, I'm off screen. Sorry. Here we go. I just distributed that negative 3. Notice here that these negative 3's drop out, and then we're just left with negative 20 over 3x minus 2 quantity squared. And there's my quotient rule. So that is my derivative of the inside. So over here for f, finding y prime, remember we're just dealing with the outside, so kind of covering that up. 5 times, just rewriting the inside to the 4th. And remember, now we're pointing at this, the derivative of the inside. But we've done ourselves a solid, and we did that prior to over here as scratch work. Oops, excuse me. So I meant times negative 20 over 3x minus 2 quantity squared. There you go. If you wanted to, you could say, okay, 5 times negative 20, or say that this is now negative, 100 times x plus 6. Excuse me, all over this. X plus 6 over 3x minus 2 to the 4th. And then I'm going to slap this front part, this denominator to the front. And that's squared. But notice I need my original inside to still be inside the 4. And that's example 8. Hopefully not too bad. Again, I hope I'm making it look easy. I've been doing this for a long, long time. But remember, be patient with yourself. You're just learning a brand new pattern on top of also getting familiar with product rule and quotient rule. So be nice to yourself, be patient with yourself, but still, you know, the faster you can learn this, the better you have set yourself up. And the last page for chain rule. Just a few word problems, they're not too crazy. The area A, ooh, that did not help. There we go, okay. The area A of a circle with radius r is cap A equals pi r squared. The radius r of a circle with diameter d is r equals d over 2. Write the composition of function of A as a function of diameter. Then find the rate of change in area in the circle per unit change in diameter. So step 1 here, let's rewrite formula of A. 2, find derivative, derivative, right? That's what this is, the rate of change in area. Find derivative for A prime. So step 1, write the new function. Step 2, find the rate of change of area. Step 1, step 2. So away we go. So far we know from the given, A equals pi r squared. We know that the radius is equal to the diameter over 2. So just by doing a substitution, right, r for r, we have that A equals pi times diameter over 2 quantity squared. So again, all I've done was I substituted r for what r equaled. So step 1, done. Done. Step 2, find the derivative. Well, A prime equals, remember that pi is just a number, right? We say it rounds to 3.14. That's it. It's just a number. It's a coefficient. Think of it as 7 hanging out. It's just chilling. Coefficients hang out. They just chill. So really here, I've rewritten it. So it's just, like I said, hanging out. So the actual chain rule is just this part right here. So the 2's what we're going to do is first, right? The outside. 2 times the derivative over 2, or excuse me, diameter over 2. And then technically to the first power, I'm going to write to the first power, but of course you don't have to. And then times the derivative of the inside. Well, keep in mind that diameter over 2 is equal to 1/2 times the diameter. Diameter is our x, so to speak, in this form, right? Which we've looked at x in the other examples. So the derivative of 1/2 d is just 1/2. Now notice that the 2 and the 1/2, they become 2 over 2, which is just 1. So all in all, we end up with pi times d over 2, or if you'd rather, pi d over 2. So this is the rate of change in area of the circle per unit change in diameter. So rate of change in area per unit change in diameter. Perfect. All right, so now I'm going to kind of throw you to the wolves. I want you to pause the video and try number 10. It's very, very similar. Okay, keep going. I'll give you hints as to how to set it up. But then I really want you to pause and try. Okay, so the sides of a square are expanding so that after t seconds, the side length is x equals 3t plus 1. Find the rate of the area of the square is expanding after t seconds. Use this formula to find the rate of the area is changing after 5 seconds. Okay, so it gives us side length, but then asks us for area. So we have to have background information on this. Well, remember that the area of a square is just equal to the side squared, right? So making a substitution here, if I know that my side length, they're calling it x, that's now x squared. Well, now just substituting for x, this is 3t plus 1 quantity squared. So really, this is the equation we're taking the derivative of. So pause the video, give it a whirl. Again, I do want you to go all the way to change what is it after 5 seconds, or at 5 seconds, pardon me. Okay, and you're back. Good, good, good. So this is chain rule, right? So the area changing of the square, we've got outside first, 2 times the inside, 3t plus 1. That comes down by 1. 2 minus 1 is 1. I'm going to write the 1 for effect. Of course, you don't have to write it. And then times the inside, or times the derivative of the inside, which in this case is just 3. So 3 and 2, that 2, this 3 gets combined for 6 times 3t plus 1. To the first, we don't have to write the first, so I'm just going to distribute the 6. So it's 18t plus 6. So now if I want after 5 seconds, we're just going to throw in 5 for t. 18 times 5 plus 6, my brain is not that fast, so I'm going to cheat with my handy dandy calculator. 18 times 5 is 90 plus 6. So we've got 96 units. I think units, side length doesn't really tell us. Yeah. This is the rate the area is changing after 5 seconds. That's it. Happy chain roll.